So I'm gonna do two things. I'm gonna do these steps. I'm gonna draw my vector v1, which is for reference. Then I'll create a transformation matrix. I'll show you how to create a transformation matrix, by the way. So I'm gonna create my vector. So I'm gonna go vector. This is gonna be v sub 1, and it will take as argument a tuple. So this will be 0, 10. Okay. Again, I don't need to pass two tuples because by default, its x and y displacement is 0 anyway. I just need to tell where the segment goes, where the second point is. So, and that's 0, 10. This will give me that straight line like before. Then I'm going to draw this vector. I'm going to go draw v sub 1, and I'm going to go obj equals ax. And for the color, just want to make it black because it's the reference vector. Okay, make sure the other libraries are imported. So I'm going to click on run all. And then when I scroll down, there is the line. Now I want to show you how to rotate this. 45 degrees. So I'm going to create my rotation matrix, uncomment that line of code. And if we look at the reference up there, it says that we need to have cosine and sine and cosine. So I already have the math library in scope. So I'm going to use math.cosine. I'll plug in the values in a second. Then I have math.sine. Then I have math.cosine. Oops, sine and then cosine, right? The cosines go on the main diagonal, like so. What number should I plug in here? And this has to be negative. So we can't put 90 because, well, we're not on a polar coordinate system. So yes, we would have to convert radian to, sorry, degree to radian. So if I show you the polar coordinate system, polar coordinate, of course, pi is the length of the unit circle. Half of that would be 180 degrees. So one unit circle is 360 degrees. Half of that is 180. A half of 180 would be pi over 4. Right? So, but let me just pull up the picture. So pi, the length of the unit circle. So obviously this would be 360. 0 and 360 are the same. Pi over 2 is 180. So half of a unit circle. And then 1/4 of the unit circle. So this L shape, we get 90 degrees. Our vector right now is here, our origin vector. So if we want to go 90 degrees clockwise, doesn't matter if you go left or right, but the point is to make it rotate 90 degrees. So let me show you two ways to do this. Converting from degree to radians, so that would be math.pi. Pi is an attribute of the math object over 4. So I'm just going to take this and I'm going to call it theta. Pi over math, pi over 4. Because I meant to put math in here. Okay. Theta. 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 There's my rotation matrix. Let me activate this code. Multiply my rotation against my original vector. And then if I want to draw my vector, I'm just going to go draw v1 sub rotate obj ax, and the c, let's make it red. And I want to use this implementation, this one. So if you remember, we said that if you want to convert from polar to Cartesian, I mean, we already went through this in the start of this session. But I want to go the other way around. So I cannot plug in the degrees because we're not in a polar coordinate system. So I have to convert the other way around. Now the radian, well, obviously it's this, but I already know what the length of my vector is. It's just 10. So r is equal to 10. But if I want to get my theta, I can use arctan. This is the inverse trigonometric function. It is denoted arctan or even tan to the power y, to the power -1. So these two are identical. Okay, sometimes you will see this notation, sometimes you will use that notation. I'm going to use the arctan function to get the theta. And to get that, I'm going to have to put y over 10. So my y is 10. And my x is, my x is 0. Okay, so let me show you how I'm going to do this. All right. So I'm going to go theta equals math dot arctan or atan, and the ratio is y over x, so that's 10 over 0, but I cannot divide over 0, so let me just make it converge to 0, make it as close to 0 as possible. So 0 0 1. Okay, I want to it's just an approximation. This is meant to be cosine. Okay, there we go. This is what I was trying to do. So yes, I really wanted to show you this implementation because so that we know we can first of all, to show you the purpose of the inverse trigonometric functions, and that this is one way we can convert back. We can alternate from polar coordinate to Cartesian. And the other solution is the radian. And the second method is to do it this way. This is going from polar to Cartesian. And this is degree to radian. Okay, let's try again. And of course, we want this to be 90 degrees, so I'm going to make this pi over 2. There we go.